Good afternoon, all of you. I'm here to explain you or to brief you about Hyperledger Fabric, a famous permissioned blockchain. And today we'll be seeing what are the differences between the public and the private blockchain. And next, we will dive into a use case and build a smart contract on top of it. Okay, so apart from that, we will be also deploying our own Hyperledger Fabric Network. So till now you have heard and listened to the famous public blockchain, that is Ethereum, and you have learned how to create an application on top of it and do some transactions even, right? So we will also see how we can bootstrap the network on Hyperledger Fabric as well, and we will write a smart contract, a sample smart contract, and deploy it onto our network. So before that, we will see the major differences between the public and the private blockchain. What makes the difference between them, right? So public blockchain, it is open to everyone. Anyone can go and access it. Everyone is authorized to do that. And you can access it sometimes by paying some tokens to the network. Next, in private blockchain, not everyone is going and can do the transaction inside the private blockchain. It has a certain permission mechanisms, it has some restrictions and access controls bounded for the network. Fine. So yeah, so access controls are very much important in private blockchain. And coming to the public blockchain, each node will have equal privileges for a transaction and data. The public blockchain's nodes are having equal privileges. How many of our nodes are there? All the nodes will be having equal privileges, and data is distributed among all the nodes in the network. Fine. And in private blockchain, there will be limited number of nodes according to the use case or the business scenario you are building, right? So that is one. And there will be certain group of nodes, and every group of nodes will have certain functionality associated with that. So every that group of nodes will have certain functions, and the purpose of that node is limited. Okay, so not all are privileged to, and not all can have all the functions, right? And the most important one, transaction per second is low in public blockchain, right? So if you have heard, Ethereum takes around Bitcoin takes around 10 minutes for a transaction process, right? But in private blockchain, the transaction, the TPS is very, very low, and it is as good as a traditional database, a solution on a traditional database, and you can build on private blockchain, right? And coming to the transaction cost, the public blockchain's transaction cost is high, and because it involves a huge, a consensus protocol which is associated with high energy consumption, and proportionately it will increase, and the transaction is comparatively very, very low in private blockchain, right? So since you are deploying private blockchain in a limited set of infrastructure, the transaction cost will be comparatively very low, right? So the consensus protocols involved in public blockchain are proof of work, proof of stake, etc., right? And nowadays, if you see, there is another consensus protocol like proof of history as well in Solana. So like that, there are different kinds of consensus protocols, and each will have its own algorithm. And coming to the private blockchain, consensus algorithms can be like Solo, ETDC, wrapped, etc., right? And in public blockchain, since there is no access control and the permission mechanisms involved in the public blockchain, there is no trust among the members inside the network. Anyone can come, anyone can do the transactions. And in private blockchain, members inside the network need to trust each other, and so the trust should be formed, and that is the reason why private blockchain became the unique one rather than in public blockchain. And next, energy consumption is very high, in public blockchain because since the consensus mechanism involved in the algorithm, in the consensus algorithms like proof of work, consume lot of energy and consume lot of computational resources. So, proportionately, it will consume more electricity as well, right? So, indirectly, everything come to a proportionately. This energy consumption is high, and in private blockchain, energy consumption is too low, and it is as good as the energy consumed via centralized database, right? So these are some pros and cons, and these are the major differences between the public blockchain and the private blockchain. Uh, yeah. So if you want to build a blockchain for a business, since business is a combined network, right, where a set of peoples are fixed and there should be some access control and there are some issues of confidentiality, and there need to be some security as well, everything. If you consider a business, there will be many factors which you need to see, and if you want to build a blockchain for that business considering those factors, so these are the factors you need to keep in mind. The first one is participants must be identified. Like we talked, like in public blockchain, not everyone can come and do some transaction in the business, inside the business, right? So, for example, take example of Domino's. Not everyone can go and build their own, own order, right? So there will be a specified person, and that person is authorized to generate the bill for your order. Fine. So it is like that. So participants must be identified before they invoke any transactions, and the network should be permissioned, obviously. So everyone, the whole network should be permission and should have a permission mechanism, and it should have high TPS, right? So say for example in Domino's itself, if the business is stopped and if one transaction is taking for 10 minutes, then it's a huge loss for them, right? Yeah, if the Domino's is stopped for 15 minutes, it is estimated like they will be losing around 10 to 15 lakhs just for 15 minutes. So it is just an estimation. It can be more than that. Fine. So for that, the TPS is very, very important if you consider a business, right? And low latency of transaction confirmation, right? So the time taken to confirm a transaction should be very, 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 very low, and it is indirectly the factor of TPS as well. And privacy and confidentiality of business should be maintained, right? So not every information can be shared with the public, and the privacy and confidentiality between among the players in the blockchain, the participants in the consortium should be maintained apart from doing the business, right? So these are some important factors you need to consider if you are deploying blockchain for a business, right? So why Hyperledger Fabric? Why Hyperledger Fabric suits best for business is the question now. So apart from before we talk about Hyperledger Fabric, we will talk about what is that. What is Hyperledger Fabric, right? So it is an open source enterprise grade permission DLT platform, and it comes under a Hyperledger umbrella project. So that umbrella project has many other projects like Aries, Hyperledger Aries, Indy, Iroha, Sawtooth, etc. So based on the use case or based on the demand, and they have their project, and one of them is Hyperledger Fabric. So it has a diverse set of maintainers from multiple organizations, and around 200 developers are working on that for developing as a community, right? So, okay, so why Hyperledger Fabric and how it uh, matches with the requirement for a business. Right. So it is highly modular and configurable. Literally everything is decentralized. Everything. I mean, every service inside the whole solution of Hyperledger Fabric is decentralized. Okay. So there is no single point of failure, and if any resource is failing, it's not a problem at all, and there will be some other resources working until it becomes active. Right. So it is configurable and you can modify it according to your use case. Right. It's not a fixed thing. It's just a framework, and you can build for the maximum of the use case you can do. Right. It supports smart contracts, which can be written in general purpose programming languages like Java, Go, and Node.js. Like, for example, if you see Solana. Okay, Solana blockchain. If you want to write a smart contract on Solana, you need to go and learn Rust for that. Even in Ethereum, you need to learn Solidity. But in Hyperledger Fabric, it is not a domain-specific language. Hyperledger Fabric smart contract can be written in majority of language. The languages which are used by majority of the developers. Right? Even you can write a smart contract in Python as well. So Java, Go, and Node.js, and Python, etc. So you have multiple options of developing the smart contract on Hyperledger Fabric. So you need not to go and sit and spend some time for learning a domain-specific language. Okay, it is also a permissioned network. So everything inside the network is permissioned. Every node, every user node, every entity in the network will have its own certificate, and they are permissioned inside the network. It has a consensus algorithm for writing the data. Before it writes the data, it undergoes a consensus algorithm like we have seen in Ethereum or Bitcoin. It doesn't require any cryptocurrency. No cryptocurrency is involved in Hyperledger Fabric, so you can do any number of transactions. Fine. And a ledger can be configured with a support of variety of DBMS. You have variety of options of database management systems like CouchDB, BigChainDB, and there is an option of MongoDB as well. But yeah, so you have the option of your own database, and multiple channels can be initiated among the organizations. Right. So we talked about privacy and confidentiality. So to maintain those privacy and confidentiality, you can create multiple channels so that not all the members are involved in that channel. So say, for example, there are A, B, and C organizations. There are organization A, B, and C. Fine. So there is a common channel between A, B, and C, and there is a requirement that you need to share data only with you. Being in org A, you only need to share data with organization B. Okay. But C should not be involved in that data or transactions. So what you can do here is you can initiate another channel between A and B where C is not at all involved, and by this you can maintain your privacy. Okay, so that is these are the major advantages of Hyperledger Fabric. And yeah, so what are the components of Hyperledger Fabric? So certificate authority is the service which maintains the permission mechanism involved. Okay, so we talked like we need a permission mechanism. So we told like it's a permission network. So we should have a service which can maintain that permission network, and that is nothing but certificate authority. So what it does is it will issue certificates for all the entities. They will be unique. Each certificate will be unique from each other, and it will be issued during the bootstrapping of network, and even after the network is bootstrapped, you can this certificate authority can be used to generate the certificates. Fine. And peers are the place where data is stored, and these peers are also used for endorsement. Endorsement is nothing but just to check, verify who is the person, or what is the entity which is going to initiate the transaction. So we'll talk it in the architecture in the next slide. But peers are the place where data is stored, and this is the place where the final data will be, and the smart contract will be hosted. Okay, so this is a very important component in Hyperledger Fabric. Ledger is the place where this ledger is hosted by the peers. Like I just told, peers is the place where the data is stored. So how that is stored is, peer will host another instance of ledger, and it will directly store the data inside the ledger. Fine. And smart contract is nothing but the business rules in terms of code. That's it. Okay, so smart contract is just will have some functions, and you can deploy it onto the network, and you can invoke those functions to create a transaction, to write some data onto the ledger. And order is the component which orders the transactions, takes the transactions and orders them. And this is the place where the consensus mechanism is involved. Okay, so we will see how it works, how a Hyperledger Fabric works. This is the architecture of Hyperledger Fabric. Okay, so say for example, there is a client. It can be anything. It can be a SDK, a Node SDK, or Java SDK, or Go SDK. So whatever client will initiate a transaction. When the client initiates a transaction, it is not a transaction, it is just a transaction proposal. Okay, we will not call it as a final transaction. It is just a proposal. When it initiates a proposal, it is first simulated on the peer, okay, where the data is already there. But please remember, data is not at all written here. It is not at all written here. It's just a proposal. When the data is written is when it becomes a transaction. Okay, so since it is a proposal, this proposal will just check what is the state of the blockchain, and takes a read-write set, and this peer will act as an endorsement peer. And by doing that, what it does is, it will verify who is the person, or who is the user who invoked the transaction, right? And it will verify the certificate which is issued by the certificate authority, fine. And it will verify the certificate, and if every parameters and rules are okay and being verified, after being verified, it will endorse the transaction. It will sign the proposal and send back to the client as a second step. Means it will just sign the transaction, it will verify and sign the transaction. It's like a security, fine. After it verifies the transaction, it will send back to the client, and the proposal will become the transaction from the third step. Okay, so then when a proposal is endorsed by the peers, then it will become a transaction, and that transaction is sent to the order nodes. Here what happens, this orderer will take the transaction and orders according to the sequence and create a block. It's a block, we can call it as a factory of blocks. So order node will create a block taking all the transactions from the client, endorsed transactions from the client. Those transactions will be sent to the channel, and that channel will send that block to all the organizations, all the peers in all the organizations which are inside a channel. Okay, so that block is again verified by the peer, whether it is endorsed properly, or what is the sequence of block, and everything. All these parameters will be verified again, whether it is sent by the order. It will verify again the order certificates, everything. So there will be some verification mechanism again involved in before writing it to the blockchain. And finally, when all the parameters are set, then the block is written to the blockchain. Okay, the final response will be sent to the client again, that it is, I mean, the transaction is successful, something like that. Whatever we do, I mean, the response will be like transaction is successful, like that. So this everything will be done in fraction of seconds. Okay, so it is based on the resources we allocate to the whole architecture and everything. There are several factors which can affect this performance, but this is the flow of a transaction from initial client to again ending with client. Okay, so first the client will send the proposal. It will reach the peer directly in the first instance. The peer will uh, verify the certificate and all the rules involved in it. Fine. And after that, it will endorse the transaction. It will endorse and send back to the client. And that transaction will be, sorry, the proposal will be a transaction, and that transaction will be sent to the order nodes. Order nodes will order and create a block, and that block is sent to the peers, and peer will send that to the client again. So this is the architecture. Fine. Okay, I got a question. Can you repeat step 5 between 4 and 5? When and where the transaction in the ledger. Okay, fine. So yeah, so once the block is created and distributed to in the channel, this channel will distribute the block to everyone. I mean, it will create the replicas and send that to all the peers who are eligible in the channel. Okay, so eligibility comes under this channel only. So if there is another organization in this channel associated with this channel, then it will send that block to that organization as well. So it will send that block, and when the peer is having the block, okay, when it is coming to when the block came to the peer, it will again verify whether the endorsement is done by it will verify the signature. Okay, it will verify the signature which was done initially during the endorsement phase, and after that signature is verified, if it is valid, then it will send that transaction, the data. It will extract the data and send that and keep it onto the ledger instance. So I did not show here the ledger instance. Okay, you can understand it better when we do the hands-on. So nothing. So you can assume that here the data is written. Here itself the data is written. So what you can assume, like that data after all the verifications across, the data will be stored here, and after storing, this peer will send a final response to the client like transaction was successful. So after that, you can query the same data from the peer itself. Okay, yeah. So, okay, we'll have a demo on Hyperledger Fabric. Fine. So I just built a small use case, very small use case, which is very much useful actually. So the problem statement here is, if you consider a bike, sorry, not a bike, a car, consider a car, okay? So not only car, all the motor vehicles in the market. So reselling has its own advantages and disadvantages. Fine. So having a resale market played an important role in automobile market, right? So because of this, many people are getting cars or vehicle, whatever vehicle. Whether it is a bike or a car, majorly this will be the major transactions. Maybe it will be a bike or a car. So they will be getting in very affordable prices, right? So instead of buying a brand new car, they can get the same car with affordable price. right? But here in the second-hand market, quality and trust are still a major challenges for anyone to buy before. I mean, for anyone before buying a vehicle, right? So what happens in a traditional? I mean, it happened to me as well. So what happens? You will go to the market. There will be a group of resellers showcasing their second-hand bikes or vehicles, right? So we'll go there. They will keep that vehicle very nicely polished, and they will make it like it is a brand new like that. Okay, so they will showcase it like that. Okay, fine, you will just trust that and you will buy that. I mean, say for example, you bought it. What happens after buying that? You will notice some glitches, or you will notice some minor problems coming slowly, right? So what happened here is the trust is lost. First of all, fine, they will tell you like this is in very good condition, but after that you will come to know that the condition of that bike is not up to the mark, bike or any car. Fine. So the problem here is information. Fine. So buying a second hand vehicle without proper information can put the buyer at risk. Fine. So if you have a provision of getting the genuine information, you can verify it and you can happily buy it. Okay, you can analyze the history of the vehicle, when it the parameters, like when it was bought, like what is the service history, what is who was the owner, what is the registration, all these things. Like there will be many parameters. So information, if you have a genuine information of that particular car, then you can at least analyze before you buy it. You will have an option to analyze before you buy it, right? So the solution is like this. So service centers of car manufacturer can share the service history of a particular car. So if they can share the servicing history of a particular car, then we can at least analyze what are the things done, what is the frequency of that car which got serviced, and how many times the like any accidents, any record of accidents, everything can be uh, uh, can be analyzed in a single view, right? So if service center of that car manufacturer can share the history of a car, then it can be viewed by reseller and the customer together. And if the advantage of reseller can be, the reseller can analyze the service history, and he or she can fix a proper price based on the vehicle's condition, right? And coming to the customer perspective, customer can analyze the service history and take the decision of buying. Okay, so based on the frequency of service, based on any accident records, based on the kilometers driven, everything uh, like there will be certain factors before you buy, and you can at least analyze. You will have an option to analyze on your own before you buy that, right? So we will build that thing on Hyperledger Fabric. So consider there are two organizations, service center. One is service center and another is cars reseller. I did not take any names here, just generic terms, service center, and let's consider in generic thing, right? And the prerequisites are the VS Code with IBM Blockchain Extension. I will show that. And you also need microfab. Microfab is the micro version of Hyperledger Fabric. Please don't consider this as a production scenario. This is just for development and just for understanding and just for testing. Majorly, microfab is used for testing any smart contract. Fine, I will share this link actually. Yeah, so that is the GitHub repo of Microfab, and you can have a read on them. It's very easy to use tool. And Node.js and Docker, you need a Docker. So Microfab will bootstrap the network inside a Docker container. Fine. Okay, so before we bootstrap the network of Microfab, we need a configuration of that Microfab. Okay, so here we have involved two organizations inside the network. So we need to write the same inside the configuration as well. So it's just an environment variable inside the terminal. Okay, it's a JSON one. I will just show you that. Yeah, so this is a JSON form. It's an environment variable in a JSON format. So what is that? There are two major sections. One is channel and another is endorsing organization. Endorsing organization is nothing but the organizations present inside the fabric. Okay, so this organization can endorse a transaction. Fine. And channel, so in that channel we need to give the name of the channel. It can be anything. I just given as my channel. You can give any channel. You can give car channel, whatever it is. But this configuration will be fixed when once the network is bootstrapped. Okay, and we need to again tell the channel who are the organization present inside the channel. Okay, so these are, again we need to specify that these are the organization present inside the channel. So whatever blocks are created, you need to distribute on every peer inside this organization. Fine, so let's export this to the terminal. Fine, and we will run a command. So this is the configuration. So here it is a sample configuration. Here you have only one org, and you have only one org. You can just copy this in a notepad and you can edit it according to your wish. Okay, your use case if you want to build anything. Fine. So after that, when you are done with the configuration, once you have exported the configuration, you can just run this Docker run. Okay, so Docker run will just run this Microfab with this, run a Docker container with Microfab, this image, and it will get the configuration from this variable. Okay, and it will run on port 880. Fine. So let us learn. Okay, so the network is bootstrapped. Another tool which we will use is VS Code extension, VS Code, and inside that VS Code extensions will be used. Just a second, let me delete the older files, then it will be clear for you. Fine. So to install this IBM Blockchain extension, you can just go to the extensions here, search for IBM Blockchain extension. So this is the extension. It will be a square box logo. So you can just click on install. It will automatically install onto your VS Code. Fine. After installing, you will get a tab here with IBM Blockchain extension. Fine. So this is the initial setup of the tool, and here we need to link our resources. First and foremost, we will link. We have already bootstrapped the network, but we need to link that network with the VS Code. Fine. So just click on add local or remote environment under fabric environments. Come to add micro, navigate to add micro fab network. Just you can add, leave the default values and give a name. Maybe you can give as car. Okay, so it's your will and wish. You can give any name just for reference. So here it has created a network car. So if you double click on it, you will get the nodes. So we have a reseller peer, we have a service center peer, we have a reseller CA, we have service center CA, we have order. Okay, so order is just for convenience. So every node is present here. So every node will have its own functionality like we discussed in the differences, right? So next comes the chain code. So the network is done. I mean, with few clicks of mouse, we have successfully bootstrapped the network. Now we will write a sample chain code. So for that, in smart contract section, you can click on create new project. Go with the default contract, and I will select with JavaScript. And here we need to specify what is the asset which we are going to do the business here. Okay, so here in automobile resale network, we will be using car. Okay, let's suppose it is a car. Car is an asset for our business. So just give enter and we will browse. We need to keep this somewhere. So what we can do, we can create a folder named resale or something like that. Okay, so we create resale and we can save, and we will add that to our workspace. So it will automatically generate a template like smart contract, which you can edit according to your use case. Fine. Fine. So this is the package or the set of the smart contract. I mean, all the files in the smart contract, and including the package.json. I mean, all the node models involved for this Java. I mean, the contract which consumes. Right. So inside, if you go to the lib directory, you will find the contract with the asset name. It's like a notation like the asset name dash contract.json. So since we have given car as an asset, it created car dash contract.js, and here we will have different kinds of functions like car exists. Okay, so what does this mean is if whether the car exists or not. It will check when you invoke this transaction. It will check whether the car exists or not. Create car. So create car is nothing but it will create a new car inside the ledger. Read car, it will just read car in the sense it will just fetch the current state of that car. Update car, if you want to update any values inside the car, then you can call this function. And delete car finally, if you want to delete that, you can just delete that. But even after you delete, it will retain there, but it will not retain in the current state. Fine. So this is the sample smart contract, and on top of it, we will write something which can be suited for our use case. Fine. So in that, we can create some smart contract functions like create car, which is already there. It will create a new car to the database. Read car, it will get the current value of the car. We can give a function called service update the service comment when the car undergoes a service. Okay. Change the ownership of the car. Okay, so we can change the owner of the car. And finally, we can have a function which can fetch the whole history of the car. So let us quickly write that. So in create car function, we have the value, right? So here we can add some more values like color of the car, and model of the car, and what we can add, owner of the car, very important, and service comment. Okay, fine. So these are the variables, or these are the data under car ID. Okay, fine. So in asset, we can we need to add all these past variables, I mean arguments, inside the asset. Okay, so what this create car will do is, first it will check whether already the car exists or not. Okay, it will just run the function car exists. It will interact with the network and check whether already a car exists with the ID which we have given. And if it doesn't exist, if it already exists, it will return like car already exists. If it doesn't exist, it will write, it will create a JSON object with the values like which we have passed till now. Okay, somebody unmuted. Any doubts? Mrudula, do you have any doubt? Okay, fine. So in asset, we will be passing all the values of that car, I mean the attributes of that car, and we will convert that asset into a buffer. Okay, so network doesn't accept the JSON format which we have given. Fine, so we need to convert that attributes into a buffer which can be understood by the network, and we need to pass all that all the JSON file, I mean with the car ID, with the function put state. So this put state will initiate a write transaction towards the ledger. Okay, so this is how we created a car. And next, yeah, I guess we are running out of time. Okay, so read car, it will just get, I mean in the read car function, you'll nothing to change. It will just if you can pass on the car ID, it will just get the whole data. So as I said, we need to convert everything to the buffer to the network. In the same way, vice versa, what happens, network will send in buffer state. Okay, network will send the data in a buffer state. We will get, if we put get state, I mean if you want to read something using get state, it will give us a buffer data, and that buffer data we can convert into a JSON, and we can read that. Okay, so here this whole smart contract has much of the functionality is like converting to buffer and buffer to JSON only. In between the logic lies actually. Fine, so we have create car, we have read car, and we will have a service update function as well. Okay, so what happens, we will write a function called service comment, and inside that we will pass to which car you need to pass the, I mean write the service comment, and what is the service comment. Okay, so we will write, okay, let us convert this as service update. That should be easy to understand. And what is a service comment which that authorized person has written. Okay, so first it will check whether the car exists or not. After that, we need to call that, I mean the existing, we should get the existing data of that car ID. We need to modify the service comment to the new service comment, and we can again send back to the network. So already I think we have used that. Let us use some other variable here. Service comment update. Okay, fine. So let us call that asset first. So for that we need to use the get state of that car. So yeah, okay, so we will call it as old update. Okay, so what happens, we will get the old data, the data of that car, present car, which we want to modify the data. We will get that car with that car ID. If we pass that car ID using the get state command, function, we will get that buffer data. After that, we need to convert that buffer data into the JSON format. Let us say like const some, so JSON of old update equal to JSON.parse old update. Dot to string. Okay, so what does is it will convert the data of that car into a JSON. Fine, and we will change that old comment to the replace that old comment with the new comment. Okay, equals let us we need to keep it as buffer here. So we'll create another variable called new update. Okay, equals JSON old update dot service comment. So the service comment update, which we have passed now. Okay, so the new service comment update will be written on the new update. Okay, okay, fine. Next, we will convert this new update to the buffer. And send to the push state. Fine. Next, this is about the service update. Fine. So what happens here is when we call the service update function, we will specify the car ID on which car we want to update the service, and we will pass a comment like engine oil replaced or second second service completed, engine oil replaced, or some changes happen to that, and we will finally pass that, replace this old service comment with the new service comment. Okay, so just a minute, I think we have updated it wrong. New update will be so fine. So next we will create another function, that is change owner. I think we have limited time here. Okay, so let me deploy the I have already a backup. I know this situation will arise, so let me give you a brief introduction, brief about this contract which I want to build, so that we can save some time. Yeah, where is that? Yeah. Fine. So here in the service update, we will give a new comment, and that comment will be replaced and sent to the buffer as a new value. And in change owner as well, since we have already the JSON of owner here, I mean owner value, so that owner will have, I mean the reseller can change from old owner to the new owner. So let us deploy this and invoke some transactions. Yeah, give me a minute. Fine. So in the blockchain extension, which we have already integrated with the network. Fine. So we will connect to the network which we have deployed, and we will package the open project. Package open project in the sense it will package whole everything inside a one file, which we call it as a package or chain code. So smart contract will be converted into the chain code. So we'll package that to tar.gz. Yeah, so we got the package. Now we will go to the my channel and deploy that smart contract. So it is already reflecting here. So you can see here the packages, the smart contract is installed on all the peers inside the network. After installing, you will have two gateways, I mean the access controls. Okay, so here we can see two organizations. One is the reseller gateway, another one is service center gateway. Fine. So first we will go to the service center gateway. Fine. And you can see all the functions which we have seen in the smart contract. Okay, so every function is customizable. You can write your own functions provided it runs, I mean it doesn't have any syntactical errors. Fine. And in that, if you want to create a car, since just now we have created our network, there will be no data, so we will add some data in the arguments. So this argument should be in the order of this create car argument line. Okay, so first argument will be the car ID. We'll give it as some car 100. Car 11100, and in the second argument it is color, model and service comment. So next is like we'll give it as black. Model we can give it as Tiago, for example. And in the service comment we can give like first service completed, and then yeah, in the fourth arguments, YOM is nothing but year of manufacturing. So I just given like that YOM. Okay, so let us fix it as 2017. And owner, finally this is very important, owner, we'll give it as allies. Okay, so create car function will write a new asset onto the ledger. Fine, so it is successful. Okay, we got a success message in return. Next, what we'll do, we'll read that car. We will just give car 110 as an argument, and we will get the data of that car. Okay, so yeah, so this is the first, I mean, you can see the service comment, first service completed. Now we will update the service. Okay, say for example, the same person came to the second service. We will update for that car. We'll update like second service completed, and we can even add like engine oil changed and something like that. Okay, so whatever things you can describe here, and not only in the description, you can write this in the big form as well, but this is since a simple demo, I'm just writing like this. Fine, so we'll submit this transaction and we got the success message. Fine, now again we will go and read the car. Okay, so we got second service completed, but we don't know when the first service happened. For that, you can just go and get the car history. I mean, you can invoke the car history, get car history, and yeah. So here you can see two set of data present. One is the first service comment, the first service completed, and you can see when, the time, and the second, another block of data, that is the second service completed, and the owner is Alice on both the case. Okay, so now we will go out of the reseller. Sometime we will, the service center, and we will go through the gateway of reseller. Okay, so what reseller can do is you can change the ownership, right? So we will just give the same car number, car 100. Say for example, Alice has sold the car to some other guy named Bob. Okay, so the reseller will just initiate a transaction with change owner and submit that transaction. Okay, so now we can get the car history of that thing, and now we have three blocks. One is for change of ownership and present owner. You can, if you want to read the car, will just give the present values. Okay, present state of that asset. So here the owner is Bob, and the last service comment was this. Okay, and if you want to get the history, the whole history of that, you can even see that with all the transactions on that particular car 100. Okay, so by this data is, made visible, and everyone can, if all the parties inside the ecosystem can come and verify, and if the data is visible, then it will be very easy for a buyer to take the decision of buying or not. Okay, I know it is a bit clumsy there. I will just elaborate it then. Fine, so this is the block, right? So initially it was first service completed, the time, the year of manufacture is same, the owner was Alice at this time. Okay, next at this time also the Alice was the owner. Now after that, Bob has bought the car, and the new owner changed to Bob. So with this raw data, you can even query, and you can query like how many owners changed for a particular car, what is the ownership history as well. So like this, you can build beautiful functions on top of Hyperledger Fabric and execute and deploy it into the real world scenario. Fine. So not only this use case, there are many use cases which can be run on Hyperledger Fabric, like supply chain and all. Yeah. So you can see this in the CouchDB as well. Okay. So someone asked me, what about Ledger? So I will show you the Ledger as well. So if you click on the car network, you can have right click on. If you right click on the car, the network name, you will find open CouchDB in browser. So in that, CouchDB is the database which we have used, the database management system. And here there are two databases created for specifically for organizations. One is this, the reseller my channel resell, and next is the service center resell. Okay, so if you go to the service center my channel, for we have created only one asset, you can create lakhs of assets. So the current value of that car 100 is being reflected here. See, so the owner is Bob, and it has a service record. The final, the last updated service record is second service is changed. I mean done, right? So the same will be reflected in the reseller as well. Fine. Same data. This data is a pure replication of, this both the parties will have the same data. Hence, the data is consistent among the network. So that is the beauty of Hyperledger Fabric.